Hi guys, this is Patrick for ScreenStudio, and today we're gonna look at ScreenStudio, the source code, and check how it works. There's a lot of people interested in how I do my stuff, so instead of writing about it, I'm gonna video about it and do a screencast. So first, you need to open the project. You need to download the source code first, of course. So go to the main website, screenstudio.chroms.com, and look here to download the latest source, which is currently ScreenStudio 1.2.3, and uncompress that content on your hard drive, install NetBeans 8, and then open the project in NetBeans 8. So I'm going to show to you. We'll expand that a little bit. So when you open the project ScreenStudio, you'll see the source packages. Basically, those are folders in the Java world, and it does work by having a main GUI which is called ScreenStudio, and you have that here in the org.screenstudio.gui. So the main file that starts when you run ScreenStudio is that one, ScreenStudio.java. So, but for starting that video, I'll concentrate actually on how it works internally, and we'll move up slowly in another video on how I use the internals from the interface. So the thing I wanted to do was to be able to parse the command line of the tools from libav-tools. In the one I'm actually talking about is avconf. If you open a console, then you can just type in and it will show you the usage of the command line. What you can do is type man avconf and you'll get all the documentation on how to use avconf and with the different options to capture your video, your display, and your webcam, and so on. So you need to learn first how avconf works, but I did it. Like, you don't need to now, but it's kind of, if you want to modify something, then maybe you need to learn about avconf first. For those who do not have access to avconf, maybe ffmpeg can do the same job. I'm currently working with the version 9.13 from Ubuntu 14.04. That's the one I'm relying on to make it work. So what I had in mind was, how can I have a software that will execute avconf in the background and provide all the parameters without getting into the complexity of keeping all the parameters in text box and having the user to choose between one value or another one. Then it hit me that why not make it simple? So I created two things. First, this is the base of ScreenStudio. So I have the class here, Encoder, that you can find in the org.screenstudio.services. This is the main engine of ScreenStudio, and what it does read the encoders.xml file, which does contain everything that has been configured to make avconf work with all the parameters and settings that you want. So what I wanted to do, instead of providing all the options to the users, I thought that it would be easier actually to provide already working out of the box settings, so users would only have to select, okay, I want to record to an FLV file, and click record, and it would work. And some basic options like quality and stuff like that, but the idea was to make it simple, because often when you work with AVConf or any other kind of power tools like that, you tend to forget after a while what was the best settings. So the best way to keep that information was inside an XML file, which is called Encoders.xml, and in that file I kind of made a list of all the parameters of AVConf that I would need to be able to capture the desktop, capture the sound from the microphone and from the desktop itself, and also overlay some kind of image with the webcam, as I discovered that it was possible. So I needed a way to have a structure where I would be able to identify the command to use and the different settings and options. So I kind of defined that in my XML file I would have nodes, and this is the service nodes. Every services are in there. Then if I expand it again, I have for each service that I can define a name and some specific options. So let's look at the Twitch TV service. So if you look into that, I simply define a node called service with a name, Twitch TV, and a target. I need a target to be able to figure out, am I recording on the hard drive or am I streaming over RTMP? So in this case, Twitch TV is a service over the net, so I simply labeled it as an RTMP target. And then I created nodes to keep the commands that I need to use. Since recording with or without a webcam is a bit different and the command gets a little bit messy with AVConf, I simply decided to have two different sets of commands, one that would support the webcam and one that would support only the desktop with the sound and so on. So I entered the two commands I needed and simply created tags starting here like that with @webcam offset, not upset, webcam W and webcam H, and all of those are defined at the top of the file. And that's what ScreenStudio is able to understand. Those tags are being replaced internally in ScreenStudio to by the values that are predefined lower in the same file. So it's a complex command, but it's everything is preset, so it's kind of easy to work with. So my commands are basically defined here, and for the webcam I've created different layouts. So this is the actual value that will be set in the command line here, and I have a title here simply stating where the webcam will show, and I have a type webcam because in previous version actually I had some other layouts available, but now I'm not using them anymore. Then sorry for the noise. The window is open and someone is making noise outside. Okay, so I wanted to have a list of presets that I can use. I could have hard-coded those values inside ScreenStudio, but I wanted to keep it generic enough, so if I would use something else, like for example GStreamer, then I could use other values in there, like could be 1, 2, 3, 4, 5, if the preset for the encoding would be different. So the idea was to avoid hard coding any value and have them in that configuration file, that XML file. Some servers are able to do have predefined server for RTMP, so though the node server is only available for RTMP services, with the file service it actually doesn't work. And then I have the crunchy stuff here, profiles. Each profile is actually meant to define in a compressed way the how the audio and video will be encoded and what muxer will be used. So basically it's kind of easy to create a new profile. You just copy and paste the content and create a new label, a name. That what is shown at the screen, in the display of ScreenStudio, and then just put the right value in here, and ScreenStudio will read, let's say, the bit rate. It will associate that value with a tag found in the command here. Oh, almost there. And if I think I need to go at the end to find it. Video bitrate, buffer, muxer, preset video encoder, out audio rate, out video rate, and here out audio rate. So the value from the profiles are inserted, replaced here wherever there's a tag. So it kind of makes it easy to anyone to just tweak those values and then create a new service with the proper profiles in servers and so on. So that's one service. If I look at the FLV service, this one, the target is file. So I know I will be recording to a file, so ScreenStudio will behave a little bit differently. But basically you have the commands, the layout, the presets, and the profiles here. So now I found a way to keep those settings in a file. I could have saved them in a database. I could have saved them in a CSV file, but the XML file is really great at using text file to keep specific information like that. And Java is actually really good at reading XML file. The API in there is really great and easy to use. So now that I have that structure of information available in an XML file, that's where it starts. The Encoder.java found in org.screenstudio.services will read the XML file. I think it starts with the get encoders here. Almost there. There we go. So the get encoders function is a static function in the Encoder.java class. And what it will do, it will say, okay, do I have a custom configuration? No, I don't have one. So if I don't have one, then I'm going to call get encoders without any parameters, which is actually this one. Almost there, just below it. And what it will do, it will first create a list of encoder, because one service, that's my mistake here, should have called that service, but it's too late. It's already created, but I will do it eventually. But one instance of encoder does represent one service from the XML file. So what I'm doing is here create a document builder that will actually be able to read the content, and then I read the content from a file if there was a file, and if there are no files, I'm simply reading the default one in my package, which is located here. So that's the one you're seeing by default. So I read that, create a document from the builder here, and then I can get the nodes like that are called services. Actually, there's only one, I think. And from that node list, I'm able to start. Okay, I found a node called services. I get a few information by reading the attributes of that node. And then below, I'm going to read another node list. Could have done that from inside. Anyway, I'm reading a list of nodes called service, which does represent actually the real service. And as you can see, I'm just creating a new instance of encoder, which is a service, and passing the node that does represent the service itself. So now I'm doing the job inside the constructor of encoder. And I'll go there. Where is it? There we go. So encoder will be created with a new instance by reading a single node, and it does know that, okay, the node does have an attribute called name, the node does have an attribute called target, and then will read those information and populate itself by reading the node. So now I know that that node, which does represent a service, does have sub-children that I need to read. So I'm doing, okay, I'm reading the first child. If there is a first child, and there should, then I'm parsing. Is it a server node? Is it a profile node? Is it a command node? If it's a command node, I'm doing some different stuff. If it's a presets node, then I'm reading preset. And each time I'm creating an instance using another class that does match each node in my XML file. So if you look here, I have the encoder, which does match the service. In the service, I can have profiles, I can have servers, I can have video nodes in the profiles. I have the audio node in the profiles also. And I'm just parsing that eventually. I have the commands here also. And I'm just building a big class that will be able to hold in memory all the information. So the encoder, the service, will have a member called other OS, operating system, backend, and version. I don't know if I'm using all of that, but anyway. I have a list, an array list of profiles, of servers, of commands, of layouts, and presets. So once the whole XML file is loaded, then all my lists will be loaded, and then it will be easier to read everything from those nodes. So it starts with a list of profiles. Okay, so each service does have a list of profiles and servers. So what I have is, if that encoder would be Twitch TV, then I would have all the profiles, all the servers, the commands, the layouts, and the presets. There we go. I got it, finally. Then what I do, because I needed to expose those collection, those lists, so ScreenStudio is able to read them and able to show them in the drop-down list you see in the interface. So that's why they are available like that, available as read-only with functions. A little bit lower, let's see. Where is it? The encoder, get encoders. Then there we go. Those are the public function, get profiles, get servers, and so on. You know the drill. Okay, so since the encoder was able to build all this, then the information is available. as you can see, now I have 3-4 functions that are called parse. The idea here is that I need to build the command line from all the settings I have and the settings chosen by the user when using ScreenStudio. So the first two public, I have 3 public command, but I think I'm only using 2 of them. I'm not sure. Yeah, I think that one I'm not using it because I tried something to stream to a URL. But okay, let's start with those. First, when I'm ready to record or to stream, I'm gonna use either one of them. So let's work only with the file. It will be easier. So I'm saying, okay, parse according to this screen, and we haven't discussed this class, but it does represent the information about your computer and what you want to show. Like if you want to have a webcam, if you have an overlay and stuff like that. So take for granted for now that screen does represent how your computer is currently configured and what region of the screen you want to record or broadcast. And this is the file that will be the output of your recording provided by ScreenStudio. So the encoder doesn't have to know where it has to be recording, doesn't have to decide. This is provided by ScreenStudio, and ScreenStudio says, okay, there you can record. So I first do a first pass. I need to build the command line. So it's a string that will hold the command, and I invoke another function called parse generics, and I'm also passing at the same time the settings selected by the users in the screen object. I'll go over that a little bit later. Once that has been parsed, I should have a fully complete command line almost. The only last thing I need to do is to replace the tag output sync with the absolute path of the file, and then I have the full command ready and available to be executed by ScreenStudio itself, the main class. So the encoder is actually just a command builder. It does read the XML file and does provide the command parsed using the settings provided by, in this case, ScreenStudio. So let's go to the parse generic, which is actually quite big. It does get the command line that was selected from a list of command object from the screen. Screen does hold the command to use. The encoder does contain all the commands that are available, but screen will have been set with the command that you want to use, basically meaning have you enabled the webcam or not, and depending on the choice of the user, you'll get the proper command line, the raw value here with the tags. And then I'm gonna check if there's a webcam and that the webcam device is at something, because I need to check that. Then I'm going to replace everything related, all tags related with the webcam. So the tags are hard-coded, and if they're not found, actually nothing will happen. But what I do is, if there's a tag called webcam FPS, then go in the screen, get the webcam, and get the FPS of the webcam, and so on. The webcam offset, the webcam width 8, the device file used, and often it will be /dev/video 0, and you'll get the layout also selected. As I said earlier, the encoder does contain all layouts, all devices, not all commands and stuff like that, but the screen is the one object that will contain the selection from the user. And then I go down. If there's an overlay, replace with the banner source. If there's an FPS, why do I do that like that? I don't know, but there's I needed to check if I've set an FPS to the webcam. If not, then I would simply select out FPS, but I just don't remember why I did it like that. There's a reason, I just don't know why. Then I set for the output FPS the FPS selected from the screen object, and then what I do after that, yeah, see, I kind of changed my mind. I did something, but I don't know what exactly I did. Then I replace any value for the desktop where it needs to be set, and then using the virtual devices. This is the screen will have a microphone object here, as you can see, and we'll do everything to put the proper audio in there. We'll talk about microphone, screen, and webcam and overlay in another video, but right now just take for granted they provide the proper devices and settings. And then I go down and okay, what is the format used? Then that's why I have 1080p, 780p, 480p, 780. Well, I think I have a mistake here. It's 720p. Oh, I had a bug. Fixed. Then 480, 360, 40, 240, and then here I do recalculate the output to make sure that it's a multiple of 2, I think, because if the output is not a multiple of 2, AVConf will fail to record. And then I replace the other tags, and that's the generic function that will provide all the values, the tags that will be replaced from the settings provided. Of course, the way I do it is not really efficient. It could be done a lot faster, but this is a one-time process when you start recording, so it actually doesn't matter, and it's not a process that is really taking a long time or a lot of memory. So there's no actually need to make it 100% efficient, like we would save every bit of information. So I could just do it quite easily and make the code easy to read and follow. So this is the internal. Those are the internal functions of the encoder class. So basically, for tonight, I have the encoder that is able to read the XML file. It will load the services as an encoder instance. It will read all the commands, the audio settings, the video settings in the profiles themselves, the server, and the layouts. And we'll simply build a structure in memory that is available, and ScreenStudio will read from a list of service of encoders what you see on the screen and display what each service does contain as possible settings that you can have, but everything has been configured in the encoders.xml file. So that's it for tonight. Hope you enjoyed that little demonstration of the ScreenStudio on how it works internally. This is a big part of ScreenStudio and was actually the key of making ScreenStudio what it is today, making it easy to work with and be able to easily add or modify features with that structure of the package org.screenstudio.services. In future video, we'll talk about org ScreenStudio services.sources, because those actually do parse and read your settings in your computers and are in charge of listing your devices. So that's it for tonight. Hope you enjoyed, and if you want to get the latest ScreenStudio, simply go to the website And at screenstudio.crumbs.com you can download the binary or simply download the source code if you want to follow up with that series of videos that on ScreenStudio how it works. Thank you for watching. See you another time. Bye.